So next, let's discuss about torque and angular momentum. What is the relationship between torque and angular momentum? Torque and angular momentum are important quantities to discuss the motion of rigid bodies. So what do you mean by torque? Torque is the rotational analog of force. Okay, so whatever role is played by force in a linear motion, same role is played by torque in the rotational motion. And this torque comes into play whenever two equal and opposite forces act on a body. That means two equal and opposite forces constitute a couple, and the moment of that couple of force forms a torque. So consider a rigid body AB which is fixed at the center O. This body is free to rotate about the fixed point O. Now just apply a force at the point A towards left direction and just apply the same amount of force at the point B towards right direction. So if here we apply a force of 10 Newton, here also apply a force of 10 Newton, but direction will be different. So these two equal and opposite forces constitute a couple. Moment of this couple forms a torque. Again, when two equal and opposite forces like this act on the rigid body AB which is fixed at the point O, what will happen to that body? Yes, the body tends to rotate, isn't it? So this is the rotational effect, and this couple of forces produces that rotational effect. Moment of that couple is known as torque. And what do you mean by moment of a quantity? Whenever you multiply any quantity with a distance, then you will get moment of that quantity. Okay, so if you multiply force with a distance, actually with the perpendicular distance, then that quantity becomes the moment of force. Okay, whenever you multiply momentum with a perpendicular distance, then you will get the moment of momentum. Similarly, whenever you multiply any physical quantity with a perpendicular distance, then it forms the moment of that quantity. Okay, so why do we regard torque as the moment of force? That you will understand in the coming session. Before that, consider a body which is fixed at the point O, and the end A of the body is free to rotate. So just apply a force at the point A along this direction. So as a result, the body is free to rotate like this. It will rotate like this. It will execute a rotational motion. And let R be the position vector of A with respect to the origin O. Now if you backtrace this force, an angle is formed here. This angle is formed between the position vector R and the direction of force F. So let this angle be theta. Here also, when you extend the vector R, you can see an angle is formed here, and this angle is formed between the direction of vector R and force F. So both are vertically opposite angles, so both angles will be equal. Now here the body is free to rotate, so obviously torque comes into play, and that torque is defined as the cross product of vector R and the force acting on that point, vector R cross F. And you know A cross B is AB sin theta, so R cross F is RF sin theta. Here theta is the angle between R and F. So this is the theta. This is the angle between vector R and the direction of F. Okay. And just rearrange this expression like this, F into R sin theta. That means consider this R sin theta as a single term. We do this rearrangement here just to find out or just to obtain a definition for torque. So the quantity on the LHS side is torque. So this is the symbol for torque. Tau. It is read as tau. Okay. So tau is defined as F into R sin theta. F means force. What is r sin theta? See here on the figure, when you draw a perpendicular from the point O to this line of force, what will be this distance? See, this side is opposite to the angle theta, isn't it? So this is expressed in sin theta. What is sin theta here? Sin theta is this opposite side by adjacent side, and opposite side is, this is the opposite side, and this is the adjacent side. Adjacent side is f itself. So this side will be r sin theta. Opposite side is r sin theta. Okay. So you know sin theta is equal to opposite side by hypotenuse, and you know hypotenuse is r. So what is this side? This opposite side is equal to r sin theta. So torque toe is equal to force into r sin theta. R sin theta is the perpendicular distance of this force from the point of rotation. So here r sin theta is perpendicular distance of force from the point of rotation O. Okay, so how will you define torque? Torque is defined as the product of force and perpendicular distance of this force from the point of rotation. Okay, so obviously torque is a vector quantity, and the direction of the torque is given by right hand screw rule that you had already studied in your class 10 physics. That means the direction of the torque is perpendicular to both R and F. And if you want, you can also apply the rule of cross product here. Just curl your fingers of the right hand from R to F. Then your thumb will give the direction of torque. Okay, so torque is a vector quantity and direction is obtained from that right hand rule. The torque will be always perpendicular to both vector R and vector F. Unit of torque is Newton meter. Very important. SI unit of torque is Newton meter. Okay. Now if the body rotates anti-clockwise, then the torque is positive. Okay, so if the body rotates anti-clockwise, then torque will be positive. Okay, children. At the same time, if the body rotates clockwise, then torque will be negative. Okay, so torque plays the same role in rotational motion as force does in translational motion, and the moment of couple of forces is known as torque. It is defined as the product of force and the perpendicular distance of the force from the point of rotation or perpendicular distance between two forces. Okay. So when you fix a handle on the door, where do you fix it? Yes, you will fix in such a way that the torque is maximum. So for this, the lever arm must be maximum. So what I have discussed just now is repeated here. Torque is a vector quantity. Moment of force vanishes if either magnitude of the force is 0 or the line of action of force, that means theta, is 0. Okay, because you know torque is R of sin theta. Okay, so if force is 0, then torque will be 0, and if theta is 0, sin 0 is 0, so torque will be 0. Okay, so the torque will vanish. Moment of a force means torque. Torque will vanish if either the magnitude of force is 0 or the line of action of the force r sin theta passes through the axis. So if r sin theta passes through the axis, then theta will be 0. So sin 0 will be 0 and torque will be 0. Okay. Now we can discuss about angular momentum. So what do you mean by angular momentum? See, angular momentum is the rotational analog of linear momentum. Okay, so torque is the rotational analog of force. Just like that, angular momentum is the rotational analog of linear momentum. So whatever role is played by linear momentum in a linear motion, that same role is played by angular momentum in a rotational motion. And angular momentum is referred as the moment of linear momentum. Angular momentum is denoted by the symbol L. L is the symbol of angular momentum, and it is defined as the cross product of radius vector r and linear momentum p. Okay, so angular momentum L is equal to r cross p, and you know r cross p is rp sin theta, where theta is the angle between r and p. Okay, so rotational analog of Newton's second law for the translational motion of a single particle will be dl by dt is equal to tau. How is it possible? As per Newton's second law, force F is equal to dp by dt, right? This is for linear motion. So for translational motion, instead of force we can write torque, and instead of linear momentum we can write angular momentum L. So we can write F is equal to dp by dt becomes tau is equal to dl by dt. Okay, so this is the rotational analog of Newton's second law of motion, where L is the angular momentum. Now, torque and angular momentum of a system of particles. If so many particles are present in a system, then what will be the total angular momentum? The total angular momentum of a system of particles is equal to sum of angular momentum of individual particles. So here capital L represents the total angular momentum, and it is equal to L1 plus L2 plus etc. plus Ln, where L1, L2, Ln are the angular momentum of individual particles present in the system. Okay. Now, similarly, what will be the total torque acting on a body? So, what will be the total, similarly, what will be the total torque acting on a system? So, the total torque acting on the system will be the sum of external torque plus internal torque. But the contribution of internal torque will be 0, because by Newton's third law, this internal forces will be action and reaction pair. So, it will cancel each other. So we are left with external torque only. So the total torque on a system of particles is equal to the external torque. Okay. So the torque resulting from internal force is 0 due to Newton's third law. These forces are equal and opposite. And the time rate of total angular momentum of the system of particles about a point is equal to sum of external torque acting on the system taken about the same point. That is dl by dt is equal to external. I have already seen that by Newton's second law can be written like this. That is torque tau is equal to dl by dt. So here which torque should come? Here only external torque will come, because internal torque will be 0. So Newton's second law can be written like this. The time rate of change of total angular momentum of the particle, dl by dt means rate of change of angular momentum. So the time rate of change of total angular momentum of a system of particles about a point is equal to the sum of external torques acting on the system. Okay. Now, conservation of angular momentum of a system. So what do you mean by conservation? What is conservation of linear momentum? In the absence of external force, the total linear momentum is conserved. Similarly, what will be the conservation of angular momentum? In the absence of external torque, total angular momentum will be conserved. Okay, so that means if the external torque tau is 0, then it means dl by dt is equal to 0. And if dl by dt is equal to 0, that means angular momentum L is a constant, because if dl by dt is equal to 0, that means dl is equal to 0 dl means change in angular momentum. So there won't be any change in angular momentum, which indicates angular momentum L is constant. Okay, so this is conservation of angular momentum, and this angular momentum of planet is conserved. Okay, so this is the rotation of planets around the sun, and whenever the planets move around the sun, there will be an angular momentum. Angular momentum of that planet is conserved. Okay. Children, with this I am concluding my session. Notes of the topic and YouTube video have been uploaded. Please go through that. We will meet in the next session. Till then, take care all of you. Stay home, stay safe, keep learning. Thank you.